All right, good morning. You guys are going to be watching this at home on your e-learning day on Wednesday. So today you guys are going to be taking a closer look at fibers. Fibers is our next unit that we're going to be looking at. It is an example of a trace evidence, which means we tend to find only small pieces, and then we're going to try to track that all the way back to the possible manufacturer, distributor, and then hopefully to find it in the suspect's home or possession. So as we look a little bit closer, there's a lot of key vocab in here that when we look at some of the pictures are going to make a little bit more sense. So definitely pay close attention to some of the different terms that you're going to hear. So again, the type of fibers, if we collect fibers, there's nothing that would make it particular individual evidence. Unless obviously if there is DNA found on the carpet fibers or things like that. So it is just classified as class evidence, but it does have probative value, which means if I can trace the type of shirt or the type of material back to the suspect in question, then that at least allows for me to again point out that they might have had the means, the motive, or the opportunity to commit the crime. So this is one that is very, very common that you would find at a crime scene. Typically, if you have a body or an individual that is left at a scene, what they'll do is they'll use adhesive tape and they'll kind of go down the individual's clothing in order to pick up any hair or fibers that might be left on the individual. We can look at the different fibers, look at them in terms of physical and chemical properties. So we will do a couple labs where we'll just look at it under the microscope and identify the weave patterns and identify the individual filaments, whereas other times we are going to be looking at the chemical properties. How does it burn? If we take a fiber and we burn it, is it going to release a distinctive smell? Is it going to shrivel up, or does it form almost like a waxy substance on the outer portion? So when we look at fibers, if we go to the smallest individual piece, that would be an individual filament. Okay, so an individual filament is like one individual strand. Okay, then the fabric is when we start to weave these together. We're going to form our fibers, and then when we take a fiber and we have one going over and under, over and under, over and under, you're going to form a fabric. Now, the general term for large textiles like cloth, carpet, rope, upholstery, that key term is textile. So filament would be the smallest that maintains the properties of the particular cloth, carpet, rope, or upholstery. And then the textile would be the larger actual sheet of carpet or roll of carpet, sheet of cloth, things like that. So that's smallest. This would be the largest. All right, so that fabric is made up of those fibers, and so the fibers are actually twisted filaments together. And so when we look at the types of fibers, they can either be natural or synthetic. Natural means that they come from organic means, which would be a plant or animal. So think of cotton. Cotton is produced by a plant, or think of silk, which is actually produced by silkworms. Synthetic would be something that is man-made, or it could also be classified as synthetic if we take something that is organic and we alter it in the lab. That would also be considered synthetic. Here are a large variety of examples in terms of organic. The ones you probably know are silk, cotton, and wool, cashmere, alpaca maybe. So those are all natural sources. If we think of rayon or acetate or nylon, spandex, think about those types of materials, how they're kind of that silky, perfect material that stretches and goes back to its original shape. Those are all ones that are man-made or altered by chemical means to give them specific properties. So why we would actually use different types of fibers are obviously we have different clothes and different uses for them. So we use cloth and fabrics for clothing, for linens, for towels, for carpeting, for sweaters, for all of our curtains and things like that. So picture any type of fabric and then what we might actually utilize that for. Here's a good example of, again, a natural fiber. You can take a look at the cotton, and right over here, you can actually see microscopic views of it. We will be doing a very similar thing where you actually get to look at the individual fibers under the microscope. And you'll notice that natural fibers tend to have more variation, whereas if you're looking at synthetic fibers, they all look pretty identical. Here's some examples of wool. We know that cashmere is really, really smooth and soft, whereas if you look at coarse wool, it kind of feels rough, or we say it's itchy when we wear it. So if you look at the outer portions of the hair, hopefully you guys remember that's our cuticle, you can see the cuticles are a little bit different. Okay, and again, microscopic view for you guys to be able to see slight variations in thickness and textures. One natural source or organic source of fibers that you maybe don't know of is flax. Flax is one of our oldest crops in the world and has been used for a very, very long time. It is stronger than cotton, but it's less elastic. Okay. We use this mostly, you can see it down here, for twine and rope. So again, if you take a look at these two under the microscope, you can notice that the natural would be over here, and then synthetic on the right. So if you notice between the cotton on the left and the rayon on the right, the rayon is more uniform. There's less buckling, there's less variation with the individual filaments as compared to over here on the synthetic rayon. Now, you might remember from the last slide that rayon actually comes from a natural source, but it is chemically altered, so it gets classified as synthetic. If we look at a fiber and think of it almost like our hair, you know how we had said that our hair is actually a cylinder, it's not just a line. Same thing with our fibers. When we take our fiber, we can actually look at the top-down view, which would be a cross-sectional view of it, and we can see different shapes. The shape that is actually produced is unique to each type of fiber and each type of filament. So one of the ways that we can actually look at the characteristics of those fibers that are found at a crime scene is looking at the cross-sectional view of this. We will do this with actually a carpet square. We'll actually look at the carpet and say, well, what does it look like cross-sectionally on a microscope? These are some of the different types of cross-sectional views that you can see. The reason why we get different shapes is because the filaments that they actually get passed through and they get pulled through is through a nozzle, and that nozzle produces these different shapes. The nozzle's technical term that you want to know is a spinneret. Okay. So because those individual holes aren't necessarily always round like this one, you can get different shapes. Those would be some of the different shapes that we could see. Now, as we look at the actual synthetic fibers, they tend to have very unique shapes. So most of them are going to be trilobal or tetralobal. And so we can actually get a number or a modification ratio, because you know we're scientists, we like to have numbers for things, and we could go to a chart and compare it. When looking at that, we could calculate the size, the diameter of the outer circle of the actual fiber divided by the diameter of our inner circle. So we would look at, if it's trilobal, obviously that would be the shape of the filament. And we would look at imposing a circle on the outside and say, well, what is that diameter versus the diameter of our inner circle there? And again, it's just going to give us another number that we could then reference back to in a chart and say, what type of fiber or fabric or film may this be? Here's a couple examples of our trilobals. So tri meaning 3, it has 3 individual lobes. You can see even from here to here, they have slight differences in terms of the length of the actual fiber. So this would have a different ratio that we just talked about on the last side. Here again is a really great view of a trilobal cross-sectional view. So again, that filament that we think is just a line, actually when we cut it in half and we look at it top down through a microscope, is going to have a trilobal shape, just like that. Now you notice that there is black fibers here. That black fiber is just used to help contrast the white fibers there, and it's the white fibers that we're actually looking at and investigating, not the black ones. Here's another great view of it under the microscope. All right, so this is where some of our key terminology starts coming in. Again, I don't necessarily need you to memorize these terminologies, but I do want you to be familiar and at least know where you can reference back to them. So a yarn is our continuous strand of fibers or filaments, and that yarn may be twisted, so it might twist multiple filaments together. The warp and the weft. So this is going to make a little bit more sense when we go to the next couple of slides and we look at our different weave patterns. The warp is the one that goes lengthwise, and then the weft is what goes crosswise. If you have a blend, it's going to be made up of 2 or more different types of fibers. So if you take a look here, here's your the warp again lengthwise, and our weft is going to be cross. And so if you've ever seen an actual weaving machine, that's what they're doing here, is they're actually going through and hand feeding that cross strand, that weft in here, and then it comes back this way, and they keep pulling this beam right there down, and that kind of pushes the actual threads, the fibers, close together so that you have a very tight weave pattern. On a plain type weave, it forms almost a checker-like pattern, so you can either actually see the warp and the weft are all the exact same width. Okay, so it looks kind of like a checkered board. So here again, you can take a look. It's a little bit easier to see on your screen, but do you see how it goes on top and then it goes under and then over and then under and then over? So that's going to happen over and over and over in order to create these weaves. For a satin weave, this one, the yarn is not actually uniform, so you tend to see more of a long float here. So there's a long float and then a short cross section and then a long float and then a cross and then a long float, and you can see kind of those nice long floats for satin. Here would be satin, so here is that long float right there. Can you guys see that on the screen okay? So all those are nice long floats. Here's another view for you as well. You can notice the longer floats are now vertical. Sometimes actually flipping the fabric over under the microscope makes it a little bit easier for you to be able to see. So when we actually try this in the lab, take a chance and just flip it over and see how it's. For twill, this one actually makes a diagonal weave pattern. So you can actually see this working down at a perfect diagonal. A good example of a type of fabric that is a twill weave would be denim. So here again, you can kind of see them working at that diagonal, and now obviously this one is kind of turned, but if you notice, it goes along the same line for our warps and our wefts. This one's a little bit harder to see, but you can see again working at that diagonal coming across for each of those. All right, so when we take a look at any type of evidence that we're collecting in terms of fibers, so remember we use those tapes, and this tape is going to be sticky, and it'll allow for you to pick up those small possible fibers that might be left at a crime scene. We then are going to go ahead and take that, and we can actually collect off the individual hairs and the individual fibers that were deposited on the individual. No matter what, though, we want to make sure that when we are collecting fabrics or any type of material that was left at a crime scene, we still are going to bag it, just like we had talked at the beginning of this year, putting it in that paper bag, making sure that it's not stored in the exact same thing if they were to cross-contaminate with each other. And then we want to make sure that any of that tape we are taking back to the lab and we're able to analyze it. All right, so if we want to look at some of the different chemical tests, it's going to be a little bit easier once we get to this portion of the lab. We are going to look at taking individual fibers and burning them and seeing how they respond to the flame. So do they move away from the flame? Do they move towards the flame? When they do actually burn, do they produce an odor, or is it just a normal burning smell? Some actually will release a smell that is very, very similar to rotten eggs. Okay, so we can do burning, we can do thermal decomposition, and chemical tests. We can look at how does it actually react, is it acidic, is it basic, and see kind of what those responses are. Obviously, the microscopic view would not be any of the chemical properties, it'd be more the physical properties. One other test that we can actually do is to test to see how dense the material is. And so in order to solve for density, this is very, very similar to if you were in Science 9 or physics. Take density as your mass divided by your volume, and we can look at it and see if it's going to sink or float in our different substances. With a refractive index, this refers back to, kind of think of your cup with your pencil. When you put a pencil in there, it doesn't actually look like a very straight pencil like this. It actually bends, and it looks like the pencil is bent. So very similar with our actual fibers and our filaments. If we put that in water, we can actually look to see how it actually bends. Does it bend towards or away from our Beck line? Okay, so that will give it a different refractive index. And just like that, that is all of our notes for our fibers unit. All right, you have a great rest of your day.